Hey guys, welcome to my channel, and we're gonna start with principles of flight and principles of flight. First, I'm generally following the portion pattern given by the DGCA on the website. So first we have basic laws and definition. Alright, so in that first topic is given as units. So units is basically, there's nothing much to explain in that. Units are very important to have a measurement, to have a standard, so that all across through the globe, when somebody is talking about a kilometer, it stays a kilometer anywhere. So units are specifically important so that we have a standard maintained on different parameters. In aviation generally, we suppose, for example, nautical mile is used, and pressure is used in hectopascals. All these are units of measurement. So that's all about units. Let's talk about laws of Newton. Laws of Newton. There are three laws. First law is a body continues to be in rest or motion unless a force is acted upon it. So this basically is a simple law to understand. Suppose a stone or a box is lying on the floor, it will continue to be in rest. It will not move unless until somebody applies a force for it to move. And suppose, say, we have a ball or a circular shaped object which is moving in this direction. Keeping all the parameters constant, it will continue to move unless until a wall or a force is applied against it. Alright, so this is first law of Newton's motion. Okay, second law states that it is basically force equal to mass into acceleration. So it states that the change of momentum, that is proportional to the impulse impressed upon the body. Alright, so it's basically when a force is applied, the force is applied equal to the mass of the body and the acceleration of the body. It is just as simple as this is the second law. Okay, the third law is the most important for the aviation point of view. To every action there is always an equal and opposite reaction. Okay, so suppose you're standing against a wall and you are trying to push the wall. So the wall is exerting an equal and opposite pressure against your body. So this is the Newton's third law. Alright, now we'll come to another topic that is there and given in the portion, that is ideal gas equation. Ideal gas equation. So this is basically PV equal to nRT. This was a combination of the Boyle's law and the Charles law. Alright, so the law is that these forms an equation taking consideration of the gas measurements. That is, P is the pressure of the gas, volume of the gas, N is the amount of gas, R is the ideal gas constant, and T is the temperature. It is just the general knowledge that you have to keep in mind. There's nothing as such that will be applying directly anywhere. Okay, so next we are going to do equation of impulse. equation of impulse. Equation of impulse is an extended second law of motion by Newton. Okay, so this is basically is, I'll just explain the small derivation that is easy to understand, I hope. F equal to m into a, if you remember we had written in the second law. So if we just separate it, this will get you F equal to m into v2 minus v1 by t, multiply t on both sides, F into t equal to m into v2 minus v1. That's acceleration. This is acceleration. Alright, so this is impulse. Impulse is force into time. So this is the equation of impulse. Impulse is force into time, that is equal to change in momentum. So basically equation of impulse is the change in momentum, that is m into v2 minus v1, that is v2 is obviously the final velocity, v1 is the initial velocity. Alright, then we will do equation of continuity. Equation of continuity. To explain in the easiest format, equation of continuity basically states that energy at local level is constant. Energy is anyways universally constant, but continuity is just energy at local level is constant. And the principle that is the inflow mass equal to the outflow mass. Say suppose through a tunnel or anything of that sort, pipe or tunnel. So basically continuity is the pressure and everything is different, but the mass inside a tunnel passing through will be same, that will come out. So basically equation of continuity is the energy at local level is constant. Alright, so next is the most important thing for us, that is Bernoulli's theorem. Okay, so Bernoulli's theorem. Now Bernoulli's theorem, I'll explain it in a very easy format so that you understand basically. So the theorem says that the pressure energy, potential energy plus kinetic energy plus any other pressure equal to constant. Okay, and let us take for an example a tube of this sort. Okay, and you're sending say winds or anything of fluid material, maybe water or anything. Alright, so at this point, if you can see, okay, at this point it's a convergent duct, at here it is a divergent duct. So in the convergent duct, the volume will increase, the pressure will decrease, and in the divergent duct volume will decrease, pressure will increase. So this is basically Bernoulli's theorem that is applied into the aerofoil of an aircraft, which I'll be explaining later. But this is important. In the convergent duct, the velocity will increase and the pressure will decrease, and in the divergent duct velocity will decrease and the pressure will increase. It's not the volume, it was my mistake. So it is the velocity that will increase, the pressure that will decrease, and the divergent duct is the other way around. Alright, so next we are going to do static pressure. Static pressure. Static pressure is when the air is at rest. This is static pressure. right now you're sitting, the air is exerting pressure on your body, that is static pressure. Okay, and there are a few key points to note. It is static pressure is the surrounding ambient pressure. Air exerts pressure all the time, and the pressure right now exerted on your body is just the static pressure. Okay, as height increases, static pressure decreases. Alright, and the third point is static pressure at a particular level will be equal. Okay, so static pressure is basically pressure of the air at rest. Dynamic pressure. So dynamic pressure, when the air is in motion, that is movement. When the air is in motion or movement, that moment when the air exerts the pressure, that is called the dynamic pressure. Alright, so dynamic pressure, we know that kinetic energy equal to half mv square, where m is the mass and v is the velocity. But dynamic pressure is an extended equation of the same kinetic pressure equation, that will be half rho v square, where rho is your density at that level and the v here is TAS, true airspeed. I'll explain in the next slide what is true airspeed, and density of that also I'll explain. Okay, so dynamic pressure is when the air is in motion, static pressure is when the air is in rest, and please note down these points for reference. Okay, so next we are going to do viscosity. Viscosity is basically the ability of the measurement of the fluid. It's a measure of the fluid, say air, water, or any sort of fluid, gel, that is able to resist the motion of flow. Alright, so for example, there is honey. It is more viscous than water. Basically, say water flows easily, so that compared to honey, so water is less viscous and honey is more viscous. Alright, so viscosity is basically the measure of resistance given by a fluid to resist flow. Okay, next is density. Density plays an important role for us, and density in simple terms is mass by volume, and the units are mass kg per meter cube. Okay, and density, you can note down these points. Density is denoted by the symbol rho, and rho is proportional to static pressure. So more the static pressure, more the density. Alright, rho is inversely proportional to 1 humidity. So if you have more humidity, you will have less density. Okay, so in example, say Chennai, where places near the coast, humidity is more, the density of the air is less, and rho is inversely proportional to temperature. So higher the temperature, lower the density. Okay, so suppose temperature is hitting highs 40-45, the density of the air is low, and hence there are further problems to fly an aircraft. We'll discuss in the principles of flight coming up. Okay, now next comes the speeds, IAS. So IAS stands for indicated airspeed. It is corrected for position error to give you CAS, okay, or RAS, that is calibrated airspeed or rectified airspeed. Okay, then this CAS or RAS, when it is corrected for compressibility at speeds TAS greater than 300 knots, this becomes EAS. Okay, so CAS corrected for compressibility will give you your EAS. Okay, and EAS corrected for density error will give you your TAS. So these points are important, just note these down. Indicated airspeed corrected for positioner will give you CAS. CAS corrected for compressibility will give you EAS. EAS corrected for density error will give you TAS, and TAS when corrected for plus or minus wind velocity will give you ground speed. So ground speed plays an important, crucial role to decide the time taken, and various factors we'll be discussing. So TAS corrected for wind velocity, wind direction and wind velocity will give you ground speed. Alright, so that's all in this video. We'll continue with the topics ahead, so keep watching, wait for the next video. See ya.